major breakthrough in oncology in the past years was the use of checkpoint inhibitors under the framework of immuno-oncology that was spearheaded to some extent by Steve Rosen's work with the idea of using immune system, and then ipilimumab came along, and we now can talk about cures even in solid tumors, which is a big breakthrough. Then from this arise a couple of questions. So while in some areas the success is spectacular, starting in melanoma or in hematological tumors, it's not so clear in other solid tumors, and we really need to answer the questions: what sequence of treatments related to immuno-oncology and what combinations will help us to treat everybody with the success we see in the responders to immuno-oncology. So that's number one. Number two is that we probably want to, even if not all patients respond, we need to find solutions to the other patients and understand why they do not respond to immune therapies, checkpoint inhibition, or CAR T cells or so. And that will hopefully allow us to treat everybody with a successful treatment related to the body's immune system. So we don't know the limitations yet, but I think a major question is the sequencing and the ordering of treatments relating in the area of immuno-oncology. Diagnostics, where I come from, can try and answer some questions by addressing the interaction of the tumor with the host and the immune system, by defining states of the immune system, ideally from circulating markers. And I think that's a second challenge, that we define the disease state in respect to a systemic treatment like immuno-oncology. And the third question is that, and I find that extremely exciting, through the advent of modern machine learning, via Jeff Hinton in 2006, where he showed us how to do deep learning, and that's with Joshua Bengio as well, that we can integrate those tools into the diagnostic arena by combining very different modalities and very different orthogonal measurements into better predictions. And that is just the beginning. We're just starting to learn how to combine molecular measurements, high throughput proteomic measurements, and imaging into useful and clinically useful tests. I got invited by Brian, and this is a novel conference for me, and I hope that by having very diverse groups of people from pharma and from the investor community and from the innovators and the smaller companies and the bigger companies, that we can find novel ways of bringing different types of data together, both for getting better guidance for treatment decisions to the physicians and the patients, making the decisions more transparent to the patients, so having more patient-centric care. And we heard today, for example, that we're aiming at better disease states and prognostic markers that are more objective than current, and thereby enabling the physicians to have these conversations with the patients and involving them in the decision-making process, and hopefully by getting and gathering the data to find and clearly define the disease states that enable the development of treatments that could deal with currently untreated conditions. And so I think we made good progress on that. I mean, it was the first meeting. I think this needs to gel, and my expectation is that after letting it sit in one's head for a while, then maybe one says, oh, I heard this at this conference, and let's get together, and maybe that's a good idea. And that's usually how things happen. My message is that, and while some of us did that, and some of us are very excited about the science and the coolness of the methods and the artificial intelligence and the biology, at the end of the day, what we're here for is to cure patients, is to help them deal with the disease. And if we keep one foot in that camp and always remember that that's what we're for, it'll lead to better progress.